In this video, we'll do this problem from December 2020 question that says that we have a point with coordinates -4, -2, 1 on the surface defined by x minus y cubed minus 2 z squared is equal to 2. Okay, and then we have to find the tangent line to the curve C. Okay, so what is that curve? That curve is the curve of the intersection of the level surface F and this given plane right here. So what do we have? So if you have some kind of surface, let's call this surface here, what is the name? S. Okay, and then we intersect this surface by some plane, let's call this plane P. Okay, and the intersection is going to be some surface, curve, and that curve is given as C. Okay, so what can we do? The difficult way to solve this is to parameterize the curve, find the equation of the curve, and we have done this previously, and then find the derivative at the point P, and that will give us the direction of the line. Okay, but there is an easier way how to do this. So let's say that this point P is here. This is the point P. Okay, we want to find the equation of this tangent line. Okay, the tangent line has, so that's R is equal to R naught plus T times R prime. Well, what is R naught? R naught is the vector representing the point P, so that's just -4, -2, 1. T is the parameter, and R prime is the vector in the direction of the line, parallel to this line. Okay, so we have the point here, that's easy, so this is going to be equal to the point -4, -2, 1 plus T times some vector here. Okay, so let's say x r prime, y r prime, and z r prime. I don't know why I use this notation, but it's a complicated notation. But anyhow, the question is how to find this vector r prime parallel to the tangent line. So this vector right here, let's say that this is going to be r prime. Okay. Okay, what do we have? If I find the gradient of f, what it will give me? It will give me the direction of the highest increase, right? So let's say that this is gradient f evaluated at the point P. Okay? This gradient is what? The gradient is normal. The gradient is normal to the tangent plane of the surface S at the point S. Okay, that means that r prime, this tangent line, belongs to the tangent plane, right? Which means that these two vectors are orthogonal. But I cannot find I cannot find r prime just based on the gradient vector. I need another vector. So the normal vector to the surface P, let's call that one the vector n. This is the normal vector to the plane with equation 2x minus 3y minus z is equal to 3, or the plane P. And then the vector n and r prime are also excuse me, orthogonal. Well, if I have two vectors, gradient f and n, how am I going to find r prime? Well, r prime is going to be equal to the gradient of f at the point -4, -2, 1, cross product the normal vector of the plane. Once we find r prime, we can just substitute it here and we're done. Okay, so first of all, let's find the gradient f. Is the vector consisted of the partial derivatives of this function here. So partial derivative of f with respect to x is just 1. Partial derivative of f with respect to y is -3y squared. Oops, sorry. And the partial derivative of f with respect to z is -4z. Now if I have to evaluate this at the point -4, -2, 1, I will simply get the vector -1. -2 squared is 4, 4 times -3 is -12, and 1 times -4 is -4. Okay. On the other hand, the normal vector of the plane is just the scalars multiplying the variables here, so that's 2, -3, and -1. Of course, somebody might say, well, can I define this surface as G to be equal to, right, defined in three variables, x, y, and z, as 2x minus 3y minus z is equal to 3, and then find gradient G. But of course, you're going to get this, just the normal vector. Derivative of this with respect to x is 2, -3, and -1, which will give us some hint how are we going to solve this for a slightly different problem later on, the problem that we're going to solve after this one. Okay, so we have gradient f, we have the normal vector. Now let's find the cross product between these two vectors. Okay, so gradient f at the point P, cross product n, right, is equal to f is 1, -12, -4, and n is 2, -3, -1. We'll find this determinant by cofactor expansion along the first row, right? So that's I times this 2 by 2 matrix, that's a -12 times a -1 is +12, minus -3 times -4 is +12. The second component, don't forget to multiply it by negative, and now evaluate this 2 by 2 matrix. 1 times -1 is -1, minus 2 times -4 is -8, so that's +8, right? And the last component is just this 2 by 2 determinant. 1 times -3 is -3, minus 2 times -12 is -24, with that minus in front is +24. And now this is very simple, it's just 12 minus 12 is 0, -1 plus 8 is 7, with negative in front and -7, and then 24 minus 3 is 21. So this is the vector that's parallel to the tangent line. Parallel to the tangent line. This vector gives us the direction of the tangent line. Well, in that case, right, I can rewrite this as -4, -12, 1, plus t times 0, -7, 21. Or if you want the parametric equation of this line, that's going to be x is equal to -4 plus t times 0, which is -4. Y is going to be -2 minus 7 times t. And z is equal to 1 plus 21t. Okay? And that's how we solve this equation. As you can see, we don't need to find explicitly the equation of the intersection of the surface and the plane. Okay, if you want to do a question similar to this one, please look at the question in May 2015. Okay, and you'll see a similar problem, and you can practice this one. As you can see, the tangent line is always orthogonal to the gradient vector, always orthogonal to the gradient vector. But what did I say here when I said that we don't, this surface in our case was a plane? It doesn't have to be a plane. We will follow the same logic if we intersect any two surfaces, which leads us to our second example, okay? And that example is from May 2019. That says, consider a level surface given by this equation, 2x squared plus 2y squared minus, 2x squared plus 2y squared minus z squared is equal to 0. And we're looking for a vector, be careful now in this question, vector tangent, they don't ask us for the equation of the tangent line, vector tangent to the curve of the intersection of S and the hyperbolic paraboloid. So as you can see, we have two surfaces, two quadratic surfaces intersecting. So the idea is the same. If you have one surface like this, okay, and then another surface, I don't know, I'm not representing these two surfaces, but and then the equation of the let's say this is the curve of intersection, and at the point P is here, let's say. Okay, if I find the gradient vector of the green surface, will give me this vector. If I find the gradient vector of the red surface, will give me this vector. Their cross product is going to be a vector orthogonal to both of them, and will actually give me the direction, it will give me the direction of the tangent line. Okay? So again, what do? I have the function f, and I find the gradient. That's 4x, 4y, and negative 2z. And now I have to evaluate this at the point P, so gradient f at the point 1, 1, 2 is the vector, well, I just plug in here 1 for x, 1 for y, and 2 for z, that's negative 4. Now I have to find a function in 3 dimensions, so I'm going to define the function g in terms of x, y, and z as 3x squared plus y squared minus z is equal to 0. And I will find the gradient of this function and then evaluate it at the given point. So this is 6x, 2y, and negative 1. As you can see, the last component is constant, so it will stay that way when I will evaluate this vector at the point 1, 1, 2. It gives me 6, 2, and then negative 2. And there you go, I made a mistake. As you can see, the last component is a constant. I just said that it will not change, so please be careful not to make the mistake that I did. So it's 6 to negative 1. Let me just make sure if I didn't do any mistake. This is minus, sorry about that. So this is minus, because we are doing this particular problem. So when I define g, this will be minus here. Its derivative is -2, evaluated at 1 is -2. Okay, so again, if I want to find a vector that's tangent to the curve of the intersection, what do I have to do? I have to find the cross product between these two gradient vectors. Okay, so that's what I do. Gradient f cross product gradient g, of course, at the given point is the determinant of this 3x3 matrix. F is 4, 4, -4, and g is 6, -2, -1. So the first component is 4 times -1 is -4 minus 2. -2 times -4 is 8. So 4. -4 minus 8. The second component is multiplied by negative, so don't forget that one. And I have 4 times -1 is -4 minus 6 times -4 is -24. So minus -24, that's plus 24. And the last component is 4 times -2 is -8 minus 6 times 4 is 24. And this gives us -12. This is positive 20 with negative in front, -20, and that -32. So this is the vector. This is the vector tangent to the curve of the intersection of these two surfaces. Now, of course, if the question was find the equation of the tangent line, if I have to find this equation, what do I need? I need the point P, and I need the direction. I already have the direction, so then R is going to be equal to the point P1, 1, 2, plus T times R prime, and R prime is in this direction. So -12, -20, -32, or as a matter of fact, any multiple of this vector. Then if you want the parametric equation, x is what? 1 minus 12t, y is 1 minus 20t, and z is 2 minus 32t. Again, the idea is that the gradient of some surface is orthogonal to the tangent line. Okay, and we know what does that mean. It means that their dot product will be 0. If you're given intersection of two surfaces, then just find both gradients and find their cross product.